Okay, so today we want to do the two-sample z-test for means. Okay? Now, to be able to do this test, obviously it's called a z-test, so you're going to need to use your z-distribution. And another thing that we're going to need to be able to do this test is both samples. You know the population standard deviation for both samples. Okay, so you know sigma for both. And the samples are supposed to be independent. And a couple of things. So what we're going to have to do is label. So we're going to label 1 for one of the samples and 2 for the other. Okay, and this will be important because if you choose 1 to be one of them and 2 to be the other, and somebody chooses the opposite, they might have a right tail test versus you having a left tail test. Okay, so it's dependent on how we label it. Okay, so potentially we're going to have 3 cases, and they're going to be based on. You could have mu1 greater than or equal to mu2, or you could have mu1 less than or equal to mu2, or you could have mu1 equals mu2. Okay, so these 1s and 2s are based on what you're labeling that population to be. Okay, then of course our alternative hypothesis based on these would, if this was greater than or equal to, then this would be less than. Okay, if this was less than or equal to, then this one would be greater than. And if this was equals, then this would be not equals. So you still have the same 3 cases. This, therefore, would be a left tail test because of the less than sign. This would be greater than, so a right tail test. Not equals would be a two tail test. Okay? Okay, so what could happen though? So let's say one of the samples was college students, and one of the samples was high school students. Okay? And I chose 1 to be college and 2 to be high school. So right here, this is for me is college, and this is high school. But let's say your neighbor chose the opposite. Okay, so you're going to have a left tail test, but if they chose the other way, they're going to have a right tail test. Okay, so don't let that throw you off. It depends on how you label it. Okay, they both would be fine, but it's just dependent on the labeling. Okay, so that's one thing to watch out for with these 2 sample problems. Okay. Anytime I introduce a new test to you, I need to tell you 2 things. What distribution does it utilize? Z-distribution. Okay, that was easy. And then the other thing I need to tell you is what? Test value formula. Okay, your test value formula looks like this. Z equals, parentheses, x1 bar minus x2 bar first, then minus, parentheses, mu1 minus mu2, all divided by a big square root. You have sigma 1 squared over n1 plus sigma 2 squared over n2. Okay? So x bar minus x2 bar minus mu1 minus mu2 over a big square root sigma 1 squared over n1 plus sigma 2 squared over n2. All of that's underneath the radical.
Sorry. Could you maybe write stuff that's under the radical up higher? I can't see.
Sure. So the radical looks like this. Sigma 1 squared over n1 plus sigma 2 squared over n2. That's what the denominator looks like. Okay, let's do an example. Okay, here we go. A statistician claims the average score on a standardized test for students who major in psychology is greater than students who major in math. The results are given below for 50 students in each group. Is there enough evidence to support the statistician's claim that alpha equals 0.01? Okay, so let's abbreviate this. So example 1 here, we have some statistician, and he claims the average score for psychology students is greater than the average score for math students. Okay, so that's how we'll have to set up the claim. They have some results, and then their question is, can we support this claim at alpha equals 0.01? So at alpha equals 0.01, can we support this? Okay, and here's your stats. Your psychology sample, the mean was 118. We're given the population standard deviation is 15, and we looked at 50. Okay, and I'm going to go ahead and label psychology as 1. So generally what I do is the first sample given, I'll label those as 1, and then the second sample given, I'll label as 2. So I'm labeling psychology as 1, so this is x1, 1, 1. Okay. And then let's do math, and we'll call that 2. And their results were 115, 15, and 50. So x2 bar was 115, sigma 2 was also 15, and n2 was also 50. Okay? So as we're getting prepared for this next exam coming up, it should be obvious that this is a 2-sample problem, right? Because we have 2 samples, a math sample and a psychology sample. Then the question is, are we doing a test for the mean? Are we doing a test for the proportion? Are we doing a test for variance? What are we doing a test of, okay? Well, the claim is the average, so that's the key word, the average score. So we're doing a test for 2 means, okay? So this is the 2-sample mean test. Then, how do I know it's a z distribution versus a t distribution? Well, if they flat out give you sigma, then it's going to be a z distribution, okay? If I change these to s's, then it's going to be tomorrow's material, a t distribution, okay? So it's the same thing that we've been doing. Okay, let's start the hypothesis test. Step 1. So we're labeling psychology as 1 and math as 2, and the claim is psychology greater than math, okay? So mu1 greater than mu2. That's the claim. So that would be the alternative hypothesis. Therefore, mu1 less than or equal to mu2 would be the null hypothesis. Okay, and again, it's based on my labeling. I let psychology be 1, and he said psychology is bigger than math. So 1 greater than 2. Okay? What type of test is this? One-tailed, two-tailed, left-tailed, right-tailed?
Right-tailed.
It's right-tailed, right? Greater than in the alternative hypothesis is always right-tailed. All right, so good. Step 2. We're back to the z distribution, so draw your normal z distribution. We have a right-tailed test, and alpha is 0.01. Okay? So hopefully this is good news because we're going back to the z distribution, which we spent the most time dealing with. So now you need to tell me the critical value on the right side. So what z value gives you 0.01 area to the right of that z value? Okay? So there's 2 ways to look that up. You could look at 0.99, or you could go on the left side and look at 0.01 on the negative side and just swap it over to the positive side. Okay? So the closest thing you can find, and what did you guys get?
2.33.
2.33, great. Your critical value should be 2.33. Okay? Any questions on that? Okay, great. Let's move to step 3. Now we have this new formula for the test value. So z equals x1 bar minus x2 bar minus hypothesized mu1 minus mu2 divided by this big square root, sigma 1 squared over n1 plus sigma 2 squared over n2. Okay? So we just plug in these values. So x1 bar is 118, x2 bar is 115, right? Does everybody see that? So we have 118 minus 115. Okay, let's talk about this guy for a second. Almost every problem that we do, this is going to be 0, okay? The hypothesized difference between the population means is assumed to be 0, unless in the question they're testing, you know, that the test is one of them's 100 bigger than the other or something like that, okay? And I'm not going to give you a problem like that. So pretty much this second part is always going to be 0, okay, unless it explicitly states they're searching for some difference, okay? So we'll put a 0 for that. And then let's go to the square root portion. We have sigma 1 squared over n1, so 15 squared over 50. Okay, and again, that's coming from psychology. And then, of course, in this particular example, sigma 2 and n2 are the same as well, so plus another 15 squared over 50. Okay, and that was just coincidence, though. It's not often that both of these are the same like that. All right. Take this to your calculator and be very, very careful with parentheses, please. And I'm getting that it comes out to 1, exactly 1. So see if you get 1.00. And the way I put this in my calculator is I just did, this is 3, then divided by square root, which opens up a parentheses, then I just type 15 squared divided by 50, plus 15 squared divided by 50, then I close the parentheses, okay? Okay, you get 1, which is somewhere over here maybe. It's not in the critical region. So step 4, do not reject HO. So if I do not reject HO, I'm going to circle HO, and I'm going to cross a line through H1. H1 was the claim, right? The statistician claimed that psychology scores better on average than math. We're not finding maths, okay? So step 5, in our own words, what happened? Will the statistician claim that psychology is better than math, and we're not finding maths, okay? So we're rejecting the statistician's claim. Okay. Questions on that one? Yes?
So when is that going to be 0 and the t-value, or not, the test value for the mean one and mean
This portion here?
Yeah.
For all the problems that I'm going to assign, that's always going to be 0.
All right.
The only time it wouldn't be 0 is if the test itself said, okay, the statistician is testing that psychology students score on a mean 3 more than math students. If that was the claim, if that's what we were testing, then this difference would be 3 instead of 0. Okay? Okay, I want to do one more of these p-value method, because we need to be able to do both traditional and p-value. So let's try another one with p-value. Okay, example 2. A study was conducted to see if there is a difference between spouses and significant others in coping skills. The results of 2 groups are given below. On one factor, at alpha equals 0.10, is there a difference in the means of the 2 groups? Okay, so we have some information. We're comparing spouses and significant others on coping skills. and we're asking at alpha equals 0.10, is there a difference? Okay, so example 2. Let me write out some of the stuff we're given. Alpha is 0.10. The question is there a difference? And coping skills. We have information, so this is our spouse's information versus significant others. Okay, spouses had X bar at 2. S was 0.6. And N was 120. Significant others had X bar at 1.7. Their standard deviation was 0.7. And their sample size was 34, okay, much smaller. Okay, so let's stop for just 1 second. If I gave you this problem, this would be a T distribution problem, right? Because I don't have sigma, okay? So I just wanted you guys to see that. I'm going to change these to sigma now and pretend that we actually have the population standard deviations, and that makes it a z-test, okay? But it's only when you have sigma is it a z-test. Does that make sense? So if this problem is something that we'll do next time, if you have S, which is usually what you're going to have because it comes from the sample, then it's going to be a t-test, okay? All right, so just to keep within today's material, though, I'm going to make these sigma. So we can do this as a z-test. Okay. What would be the first thing that you would do on this problem? HO, H1, right? What am I going to have to do because there's 2 samples here? Label one of them 1, right? So you guys can label however you want. Usually I just choose the first one to be 1, the next one to be 2, and that's important because all of these get 1s, all of these get 2s, and it makes a difference when we plug those into the actual problem for the test value. Okay, let's do HOH1. The question is there a difference in the mean? Is there a difference? Is that 1-tailed or 2-tailed? 2-tailed, great. So mu1 equals mu2, mu1 not equals mu2. Okay? Now, on this problem, there's not a specific claim, right? It doesn't say the statistician claims that psychology is greater than math. It just says, is there a difference? Okay? So later on, when I want to tell what happened in my own words, I want to know what I'm rejecting and what I'm not, okay? So I'm just going to put in parentheses, this is saying that there's no difference. This is saying there is a difference. Just as a reminder for later on, when I put it in my own words, what happens. Okay, step 2. I do my what? Oh, I wanted you to do p-value method in this problem, right? So let's make this a p-value method problem. What is your second step in a p-value method problem?
Straight to the test value.
Straight to the test value, very good. Okay, so spend a couple minutes, plug in these numbers, and tell me what your TV comes out to. Okay, we're doing p-value method for this problem, so go right to the test value. And again, be super careful with the parentheses and the square root. Okay, when I'm plugging this in, I'm getting about 2.2735. So make sure you get approximately 2.2735. And again, it's crucial that you guys can plug this into your calculator correctly because it's a shame to get all of this set up correctly and then not be able to plug it in and getting the wrong answer, okay? Because again, I grade each section, so once it goes off the rails, it's going to be really hard to give credit. Okay, so make sure you get approximately 2.2735. Then, what is the next step in a p-value problem?
Find the p-value.
Yeah, find the p-value, right? So what do? I draw this picture. I have the z distribution, and I just put down wherever my test value is. My test value happens to be approximately 2.27. I'm just going to go to, that's on the right side of the z picture, okay? Because it's on the right side, I want the area to the right, and that's going to be what I need to look up, okay? If it was on the left side, and it's a two-tailed test, you just do area to the left. So this is a two-tailed test. It's on the right side. I want to look up area to the right. So look up 2.27. And you're going to do 1 minus that. Or if you want, you could look up negative 2.27. And that will be 0.0116. Does everybody see that? So 0.0116. Okay. I'm really glad I asked this problem. When I'm doing a two-tailed test, what do I have to do with that area for it to be the p-value area? It's only in a two-tailed test. What do I do?
Multiply it.
Multiply it by 2, okay? So this times 2 is my p-value. And that only happens in a two-tailed test. So please put that in your notes as a reminder. This is a two-tailed test, so I had to multiply that by 2. And that comes out to 0.0232. So your p-value is 0.0232. That's my p-value. Okay, step 4. This is my p-value, 0.0232. This is alpha, 0.10. If my p-value is less than or equal to alpha, I reject HO, right? If the p-value is small, we reject the null hypothesis. Is this 0.02 something smaller than 0.1 something? This is definitely smaller, right? 0.02, smaller than 0.10. So we reject HO. Okay? So I'm rejecting this, and I'm circling this. And I'm glad I labeled this earlier because this is saying there is a difference in the average score of coping skills. Okay? So 5, yes, there is a difference. We were comparing the average score of coping skills versus spouses and significant others, and we're finding there is a difference. All right, there's a lot of things going on. You guys have to, I don't know what to say, do your homework and make sure that you're on top of this because this next exam is a killer. Honestly, it's the hardest test by far. Okay? Questions on this one?